Welcome to this week's Tanzu Tuesdays. Nice to have you all joining, as usual. So today I have Deshawn helping me out, being my co-host. And Deshawn got our lovely guest here, Bryan. Hi, Bryan.
BK. For those close enough, BK.
Yeah. I think the only other person that I've known who's gone by BK was like the former like Intel CEO. But that's
same.
it.
They're right. Yep. Same.
Funny.
It's kind of a title, BK.
Yeah, like it's always this thing of like, is it the first initial of the like first name and the middle name, or is it the first name and the last name? Like sometimes I go by TJ because I'm lazy, but I don't like Tiff, so it's like.
I get it. Scott Rosenberg is in the building, in the audience. Hi, Scott. Thanks for joining.
Hey, Scott. I love all this, like all the episodes with Scott, and then Scott being part of the episodes by like joining. It's just so much Scott time. It's great.
He's a super fan.
I get it. I totally understand.
So how do you two know each other, you and Bryan, or BK?
Boy.
That's a good question.
That's a good question.
We live in the same area, Kansas City, and we both worked. I worked for one of the other big spring shops here in the area, and he was across town at Cerner. I was at Garmin, and we were in the same ecosystem, right? So we're both, big fans, and we like to present and share. So we got to see each other along the way, and then 2018 we got to work together.
Nice.
So, we worked together side by side for quite a while.
Yeah, it was awesome because we had crossed paths at meetups quite a few times, and then we got to work together for pretty much 2 years. It was a good 2 years. Yeah, it was really good.
Keith, welcome.
Yes, always looking forward to more Tanzu application platform awesomeness. I'm looking forward to it as well.
So cool thing.
That's what we're going to be talking about. Cool thing, yeah.
We've had a lot of conversation over the past couple of days, and actually the past couple of weeks. Bryan is he's awesome at delivering a platform, that platform experience. One of the things that I look at is he's got that ability to, I understand the infrastructure well enough, and I understand the developer experience well enough. And he's kind of right in between, where he can talk the talk on both sides of the equation. And this is kind of a cool move that I think there's lots of companies that are doing. They're like, hey, Kubernetes is cool. We're heading that way. And even for the big enterprises, even for our existing customers, just the community in general is trying to figure out how they can take things for a spin, but kind of remove that barrier to entry. And I think Kubernetes in general is getting a little bit easier to adopt. Bryan's going to share this really cool story, and he's got a lot of background on delivering the platform. So it's going to be a cool journey, I think.
I'm excited. I'm ready. Are you ready, Bryan?
Oh, yes, I'm ready. Absolutely.
Want me to switch it to screen sharing?
Yeah, that's fine. We'll go there, and then I'll give a little bit of background. So I am a huge Cloud Foundry fanboy. And I'll just start with that. I've been using Cloud Foundry for 4 years, and let's see, I've been running in production for almost 4 years. Seen unbelievable benefits from it, and I always start there because the dream that we've had in Cloud Foundry was we never wanted to compete with Kubernetes. It was always something that made sense in combination with, because the developer experience on Cloud Foundry was second to none. It makes even the most frustrated developer happy. If I can put a smile on the guy who's always grumpy's face because his code's easy to get to production, that's made my day very, very happy, because I've been a developer. I've had code sit on the shelf for weeks at a time because it just didn't get deployed to production. for a variety of reasons. So we came to be a part of a design partner program on Tanzu application platform. We'd been kind of following along, and we were very interested because we wanted to see those same outcomes that we see in Cloud Foundry on Tanzu application platform, or I'm going to probably call it TAP from now on just because it's a mouthful. And then I'll say CF when I'm referring to Cloud Foundry, just so that we understand the difference. And one of the things that I also truly believe in is when we got started with Spring and Spring Framework and Spring Boot when it came about, it was always a ground root or grassroots effort from the devs. Devs picking up software, having the ability to run a Spring Boot application on their laptop was a huge paradigm shift. Now, almost probably 5, 6, 7 years ago. It's been a while, right? It's been a while. And the idea with Spring Boot was to make it quick, right? Be able to code a little, run a little, code a little, run a little, and you can see your application evolve very quickly over time. And one of the issues you have is now you've got this thing that's easy to run. You can do Java jar, right? Run my jar. Boom. I can run it anywhere Java's at. Great. Perfect. Now I've got something that's easy to run. But one of the things that we're seeing emerge is, well, how do I get it into production? And Cloud Foundry was, and I would still say, has an unbelievable, easy API-driven approach to getting my application into production. You know, it was Java jar, got my Java app to run. CF push, got my Java app in production. Okay, that was huge. And if you're not familiar with Cloud Foundry, go read about it. It's pretty awesome. It's got some great stories out on the internet. But what if I could say, let's get that same experience on Kubernetes? That is what we are hoping TAP ends up being, is that same developer experience on Kubernetes that we know and love from CF push, but with a little bit of Kubernetes magic sprinkled in. So one of the things that I've been trying to do is as part of my evangelism at Cerner, which is my employer, is, hey, let's make it easy for devs to kick the tires on this without having to go and ask for a Kubernetes cluster from operations, go to finance and get billing set up to go get an EKS cluster out in Amazon. Couldn't we enable the developer with a local development experience? And it was a thought I had, and then it kind of came together really quickly. It was about 13 days ago. And when I finally figured it out, I hit Deshaun up and I went, you're not going to believe what I figured out. This is amazing. So we'll kind of walk through today what that setup looks like. So if you're not familiar, you can do the Kubernetes SIG has put together a kind SIG, which is Kubernetes and Docker. It's been around forever. And it has some great documentation on how can you get this going? How are we going to make this happen locally? And I was inspired by a talk actually that came about from David Sayers at Spring One, where, and I'll just do a quick call out to it, where he did an example kind setup for KPAC. So KPAC is a really great way of getting container images built on Kubernetes, using Kubernetes clusters to build images. And we'll talk more about KPAC later because there's a component of TAP that is KPAC. But his talk was inspiring because he did all of this locally. And I love that. I didn't have to have Docker Hub credentials. I didn't have to have credentials to my enterprise's container registry or to a cloud container registry. I could have autonomy locally. So one of the things that we need to do, and the Kind group has done a great job of documenting how to do this, you can easily create a cluster and a registry on your laptop. And that's where the inception of this was the ability to do this locally. So I kind of created this really simple Kind script based upon David's and based upon the SIG's work. And a couple of things that I changed. The registry name is dev.local. The registry port is 5000. You'll see the reason for that is there's a lot of sample accelerators that are in the TAP ecosystem, which I don't think we'll have time to get to, that actually use those as the default. So it makes it even easier to just run an accelerator, which is kind of like start.spring.io, to incept a project from start. But you do this kind setup and you're going to end up with a local Kubernetes cluster. So if we jump over to our IDE here, we could do kind clusters. And we should be able to list those if I remember right.
While you're doing that,
yeah, go ahead, man. Go for it.
The last 2 weeks, we've been talking about Tanzu Community Edition. And right now, you are looking at TAP for Cerner. You're trying to kind of bridge the gap between your developer's experience and the platform. You're trying to give them the keys so they can do this, again, on the laptop. And this is kind of a big deal because when we worked together, there was very few of the engineers that you were supporting that were running CF Dev on their laptop.
Too much memory, too hard. This can create a cluster. And I'm going to not waste the time here of creating it, but if you run kind setup locally, you can get a cluster up and running in under 5-10 minutes. You can do Minikube too. There's nothing that says you have to use kind either. Kind is just kind of, it's very kind to us. We could start there and get up very, very quickly. The other thing that the script does is it ensures that we have a container registry that's local, is whitelisted by our Kubernetes cluster to say, hey, it's cool. You can use this insecure registry because it is local. We're going to trust what's running locally because we're not going to put any credentials on it. We're not going to put any SSL on it because we're trying to go fast. We're trying to get up, running fast with minimal effort. So at the end of this, you'll end up having just 2 containers running. I've had mine running for 13 days now, which is you've got the dev local registry container running in Docker, and then you have a Kindness node running in Docker. And one of the things that's really valuable about this is you can, and I put this in the script here, you can basically say, hey, where is my registry running? And if I run this command on Linux anyways, it tells me, hey, I'm running on 172.17.02. That's the IP address. And in this case, per what David also did, if you put that in your ST host, you're able to now, you could interface with that registry locally. You could do with some work on Docker CLI or with other like image pack, you could interface with that and push images to it. You could pull images from it. That's kind of the first step in simplifying running TAP locally is we're going to have our own registry and our own cluster. We're not sharing this with anybody. We're basically doing on demand with our own CPUs and our own RAM on our laptop. So the next thing that we do is we just basically target that with kubectl. This is at this point after line 12, this setup process is pretty much the same regardless as if you're doing TAP on kind or if you're doing it on EKS or on AKS or on OKE or on GKE. Pick an acronym for Kubernetes. The idea is it's pretty much the same. So we first will go through the process of doing what's called cluster essentials. You won't have to do this on TKG, for instance, because those I think come already on it. You won't have to do it on Tanzu Community Edition because I believe most of those bits are shipped with it. But what it's putting on the cluster is it's putting on the KApp controller, which I know we've talked about in previous talks. It's putting on the secrets controller. These are fundamental, essential components that TAP needs in order to install itself.
Yeah, so this, again, we've kind of gone down the Tanzu Community Edition path, and this is specific. So I'm going to try to set a little bit of the stage. You have a paved path to production, a pretty popular and mature paved path to production, and that lands on TAS. And what, correct me if I'm wrong, but this is kind of a way to take some of those developers, take some of those workloads, give them another path or an extension to that path that still goes to the same production, but whether it's on TAS or TAP, it depends. But that's all a part of your supply chain. So what we're doing here is, this is really specific as an example of how you, as a platform operator, are going to share with your engineers an alternate path to production.
Yes, because what we've learned is Kubernetes in its inception here, it's mature, it's maturing. There are still paper cuts that happen as we upgrade. They can happen to workloads, they could happen to TAP, they can happen to Kubernetes itself. And what we're trying to have is a really fast feedback loop to production updates. So my idea was, hey, how is platform engineering going to test the new release of TAP? Oh, I think we could run it on our laptop. How is a developer going to see that their workload's not impacted by the new version of TAP or Kubernetes? Oh, that's right. They could see that the release came out. They could go and pull that down, no different than pulling down a new version of Spring Boot, and they could test it. And not every engineer is going to do that. I'm not expecting them to, but if you curate, this is the version of TAP that we've done, this is the version of Kubernetes that we know works with it. We have to curate these things to match what's going to be in production so that we can give the same experience to developers in their local workspace. It's not as simple anymore as just saying, here's a Java SDK. What's the version of it? It's version 11, whatever. Okay, perfect. You should be good. It's more than that now. It's an ecosystem. And that ecosystem, I'm finding, can exist on my laptop and make me as productive on my local developing device as it is out in a cluster. There is definitely going to be those that are like, hey, just give me a cluster with TAP on it. I don't care how. It's the PASMA philosophy. That might be perfectly fine. Go for it. I don't think there's anything wrong with it. In fact, for many of my teams, that probably will be sufficient. But for new adopters, people who are wanting to do code, get their hands dirty, or if they're in platform engineering, this might be pretty useful to them. So you got to go through these steps. It's cluster essentials. In this case, I also automate the installation of the Tanzu CLI, and then we do the Tanzu application platform installation. And this is where I think Tanzu is starting to contribute something very interesting to the Kubernetes ecosystem. When you're looking at Kubernetes, a lot of people are saying, hey, this is the operating system of the cloud. You know, maybe you could take that philosophy and go, okay, if Kubernetes is that of the cloud and the binaries that run the software is containers, we're kind of missing, well, how do I curate a set of containers that are all known to work together? And, you know, one way that we could do this is we could easily use Helm. Helm's not horrible. Helm could work in this case. The Tanzu group has taken a slightly different approach, which I have found extremely interesting, which is through Carvel and KApp, they've created this thing called a package install. And the package install is just utilizing already existing concepts in the container management world and in the container registry world where, hey, I'm going to give you a container registry. That registry is going to contain all the packages, including a package of things that are known to work well together. And we can take and install this package repository, no different than adding a package repository to a package manager like apt in Ubuntu or Debian, or to Yum like in Red Hat, or this is the Tanzu package management dialect that they're bringing to the Kubernetes world, which I think is solving a very important problem, which is here's the curated set of OSS components that we all know work together. And you pull that just from a registry. So the first step is you're going to have to, you're going to have to put the secret into your registry. You're then going to have to point your package. You're going to have to add the package repository. Once you've added the package repository, you actually can then say, hey, what packages are available for me to install? And again, this is running on my local. It says, hey, package, tell me what packages are available. And this is the listing of all the packages. They can put in all sorts of descriptions, the version, the name, the package name, the display name. And this is really, really useful. This gives you a bill of materials for each of these things as well. And it tells you like, hey, if you're going to go do cartographer, here's the version of cartographer that we have that we know has worked well with this version of build service, which we know has worked well with this version of accelerators or cloud native runtimes, and so on and so forth.
So
Very
now
powerful.
I'll jump in. I'm reminded of an earlier conversation we had. Bryan is one of the people that made me realize kind of the OSS way of doing things when you're in the enterprise, right? Hey, you're using these OSS tools. You have expectations. If something doesn't look right, he's the person that says, hey, I tried to do this thing. I expected this to work. It didn't work. I'll try it again. Here's my output. And he knows how to deliver those use cases, those issues that, hey, here's something that didn't work, but it's automatic. In an earlier conversation, we were talking about this, right? You've got other teams using Kubernetes and getting the right blend. Hey, does this work with this? Does this work with this version? And as we were talking about that, of course, he already had a ticket. Hey, this doesn't work with this version, which is just an example of how we document things and having that feedback loop. One of the things that you've been really, really good at is sharing your feedback, right? No matter where you are, no matter what you're doing, hey, I tried this, I expected this, I didn't see it, or I did. Excellent work. Love that feature. And there's value in that. And if there's one thing I can share is you have kind of been that example where providing feedback, taking those early releases. We also talked about paying attention to the milestones on spring releases. Just that ability of staying current, seeing what's happening, and providing feedback, positive and negative. High five.
Yeah. It's and to that point, so I was trying out a capability in TAP, which is service bindings. Ran into an issue like Deshaun was talking about, and I always like to do latest and greatest until it shoots me in the foot. And I had done latest and greatest version of Kind. I did 122.5 at the time, and 122.5 made sense. I tried it. It installed fine. Everything installed fine. But when I went to go exercise service bindings, things fell apart. And then we found some issues, and I linked to those issues. And what's great about that is then, had I been the first reporter of this, I have a repository that says, here's how I stood up Kind. Here's how I have my TAP environment installed, which included the service bindings package. I can point to how I've done that. And I have this living and breathing reproduction repository that's in the public space that I can share out to the engineering teams that don't work at my corporation. Because one of the problems you have in enterprise development is sharing, hey, this thing's broken over here and it's broken in some vendor code or some OSS code. How do you do that reproduction? How do you get that repo back to the engineering team? And Deshaun's hitting on my thing is my BK tip of the day is always have a reproduction of an issue that you have and share it with your open source community or with your support analysts that you may have from a vendor. It will expedite support tenfold in my experience. So coming back to where we were in our install. So we've got all these packages installed. I'm not going to go through the process of actually installing TAP today. It's going to take about 20 minutes for it to just pull all the content off the internet. No one needs to see me do Docker pull all day long. But just understand that once I had Kind installed, once I had the essentials installed, it's literally Tanzu package install or update TAP. And if we look at, there's a TAP values template that I include here, which is the MVP that I found to getting TAP up and running on my laptop. I've excluded some packages to make life faster. So this was a feature that was added. So we go ahead and do the full one. I exclude things because there's certain things I want to do in my local development, such as service bindings, service provisioning. I want to test those things out. I don't necessarily need accelerators or TAP GUI when running locally. I'm going to use the out-of-box supply chain. In this case, it's pretty straightforward. Like I said, we're referencing our local repository in both cases for build service and for the supply chain, which we'll touch on here in just a minute.
Go down to excluded packages because
yes,
these are some practices, and this is some things that I got excited about. In the past, I'm looking at line 31, your accelerator.
Yeah.
One of the practices that you've had for years is here's a reference implementation of a project that will support on this path to production. Your team will support projects that look like this.
Yep.
And it started off with Spring Boot. If I'm, correct me wherever I'm wrong. But then you grew. And as you had more success by following this practice of, hey, here's stuff that we support. Oh, we don't support that right now. Oh, you want database XYZ? Yeah, we don't support that.
Right.
But you've kind of put into place channels for communicating, channels for understanding priorities of what your internal customers need.
Right.
But that practice of having those, here's an example of the types of workloads that we'll do. It moved from Spring Boot to .NET to Ruby to Go to Node, Python. Like you had this, but everything went down the same path.
Yeah.
And I automatically think about what that's going to look like for you and your internal customers now that you have Accelerator.
Yeah. And to be completely honest, there's nothing that would keep me from sitting here and unexcluding the Accelerator package, add in the little bit of config that it needs it needs the tap GUI as well. So I have to bring those packages in, add the necessary config. And whenever I run this install, it would then also include the tap GUI and the accelerators running on my local. I was just trying to do an MVP. So in my MVP, that wasn't in the scope, but I would think the next turn of the crank, the next iteration, if I was working on, let's say, writing an accelerator, I'd have those bits turned on, tinkering away at doing my local development on accelerators, and then start publishing my accelerators for other developers to make use of. You're absolutely right on the money.
I have another question for you, and this is a topic that's come up. Platform teams are busy. We have your story of supporting one workload to 10 to thousands of developers with just a handful of people.
That's right.
And platform engineers are always being asked to deliver more with less, and they don't have time to write accelerators. They don't have time to do those extending that paved path because they're constantly doing the onboarding and all the other pieces. And that's the other thing. You kind of had a practice, and you still do have a practice of, hey, this is how people get onboarded. This is how workloads get onboarded, the checks and the balances. And the accelerator topic has come up. I'm going to assume that if you needed a Python accelerator, something that say, hey, this is what it looks like. This is how we support Python apps. This is the framework, an example of what it looks like going to production. I assume that I know that person or who that person would be in that case.
Right.
Have you thought that far ahead?
Absolutely. We've actually gone one step further. So what our theory is, and this is just a theory, but we're building off of things that we did in Taz with other things in Cloud Foundry, is accelerators can be inner sourced in your enterprise or in your startup. It doesn't even matter if it's an enterprise anymore. You can inner source those. All an accelerator would have to be, let's see if I could poorly go to a web page really quick. Let's see here.
Yeah, we've had these conversations.
So yeah, if you go out here, I can't Google them very easily, but I'm not going to try to get to it right away, but there's a way to you can have accelerators backed by a GitHub repository. And then they get included dynamically to the catalog. So you could have it crawling your GitHub for things like it's in a certain GitHub org or a GitLab org. It has a certain, label on it. Who knows? Pick your poison, but it will get picked up automatically. So when you inner source that contribution, the platform team doesn't have to be the gatekeeper. They're just providing the service in the API, right? Same with Tap GUI. Tap GUI is based upon Backstage. And Backstage has got some really great Git integrations and some other source code management integrations where it can pull information from GitHub, build a dynamic catalog of known workloads. So things that you may want to deploy in your environment, like later on we're going to get to like a Spring Cloud config server or known recipes for deploying a Eureka server. Or known recipes for deploying, I don't know, pick something.
Spring Cloud Gateway. Yeah.
Spring Cloud Gateway.
Yeah.
Sure.
Got tons of
maybe.
options. Awesome.
Maybe.
Sorry about the tangent.
There's things in Python too that may make sense. Like here's a
Yep.
recipe for getting this machine learning thing
Well,
out here.
The pattern was we had config.
Yeah.
And what we were doing was we set up these config clients in the different languages so they could consume that pattern of how you're going to deliver configs on TAS.
That's right.
Now we're going to change. So you got to straddle your workloads that are going to Kubernetes and to TAS. And that's why I think you started with config service, because it was such a core part of the current path to production. And you want to be able to create a bridge.
Right.
You'll get to
you got to, yes. And so moving on, there's other things that I think we could spend an entire hour talking about that's excluded that I think would be amazing to conversation topics. So we'll just proceed. So what I also try to include, and the team at Tanzu did a great job of doing, I do want to call out, they have some fantastic documentation on getting TAP up and running. Come out here, read the docs. They're not hard. If you're looking for the Cliff Notes, though, that's basically this repository. I've distilled those down. I've even included some real simple ways of, there's some steps where they need to go and grab something off of Tanzu Network, such as for the cluster essentials. I include, hey, here's where it's located using the PivNet CLI. So you don't have to go hunting around UIs to go pull that thing down. Same with the Tanzu CLI. It comes off of Tanzu Network. They have the old PivNet CLI. You can go use that, get the product slug in there, get the version that we know works, get it on there. The other thing that this is doing is it's versioning the things that I'm getting from my vendor to install locally without having to and go through their appropriate channels of obtaining the stuff. At least they provided me a CLI and they provided me catalog information to use to go and get this. We've done the same thing in our platform automation. We're just basically saying, and we're sharing to all of our developers, hey, this is how we're doing it. This is how you could do it too. So it's very, very powerful. So with that being said, that ends up being our install. The last thing that we have to do is for every namespace that we add, we have to basically put together a RBAC document in Kubernetes that will basically say, hey, these are the things that you have access to. And also here are the registry credentials that you're going to use when publishing the containers that you're building in your namespace for use in running your workload. In our case, we're using a local one. This is heavily simplified. Username and password are really no ops. They don't matter here. We put something in, it just works. What this has then set us up with is if you can think of basically once we've gotten past this step here, we have an environment that can host applications on a bunch of different open source technologies. Let's go through what those open source technologies are really quick, very quickly. So to start at the very beginning, we have the namespaces that we're working off of. API portal is just a portal for getting ingress into the server. Very simple stuff. We're not going to get into it too much, but it's very, very powerful for API proxying purposes. We have the build service. So we talked earlier, we had a mention to KPAC. This is a callback to KPAC. KPAC is the OSS name of Tanzu build service. Build service, just real lightweight, has these following packages or pods running that provide a CRD to your environment for building containers. This is basically, if you're familiar with Cloud Foundry, this is Cloud Native Build Packs Reimagined, or Build Packs Reimagined as Cloud Native Build Packs on steroids. So one of the things we used to have in the Cloud Foundry world was it would automatically rebuild the container images with new base OS images every time we would publish one to the platform. This is going one step further. We have got this configured here through our TAP configuration in our template. We have enable automatic dependency updates. That means whenever on Tanzu Network, a new build pack, a new OS base image, or a new, really it's just those two things now. Whenever new image layers basically are published onto Tanzu Network, I can configure my environment to automatically pull those. So if I go to network.tanzuvmware.com and go Tanzu build service dependencies, this is where all that information is coming from. And on March 3rd, we had a release. So we had 100.0.271. That included a bunch of updates to a bunch of image layers that we may have used to build our containers. Some of those items might have been Tanzu build packs for, Java. Could have included a new Java update, could have included a new base image, could have included new Node.js releases. And what's really, really cool about this is being done and updated every day. We can have Tanzu Network checked to pull down these new dependencies, and it will rebuild all of our containers that we've built on our cluster. And one of the ways to know how that's going is if we do kubectl git Tanzu net dependency updater from the build service, we can actually get back, the latest descriptor version was 100.0.271. We did a last import of resources was successful. That happened on March 6th. And this is really powerful because now you basically have a CI loop on your laptop with the latest and greatest versions of all the build packs locally. Go for it, Sean.
Locally,
yeah,
you had that enabled, and you took an update of one of those container layers.
Yeah.
That's pretty slick.
So what's really cool about that is let's actually get to a workload. Let's get to a workload. I think a workload will help tie this all together. I have an example application here. This is a REST application for those who aren't aware of it. It's in Spring Boot. It's using a dependency called Spring Cloud Config Server. I've chosen this as a demonstration because it's a known REST server that I can talk about in OSS. Just a Spring Config Server provides an API that services up YAML documents. If you're familiar with Spring Cloud Config, this will be pretty much, this talk isn't about Spring Cloud Config, it's more about how could I get Spring Cloud Config running on tap. The other thing that we're doing here is we've got our config server workload. So we've authored a workload, and you'll see that this is in the documentation. This one's really straightforward. We've done some things. We've configured, hey, here's where our get source is. But one of the things we're wanting to avoid doing is every time I make a code change, having to commit to Git in order for it to reconcile on my Kubernetes cluster. So for local development, if I was wanting to make a code change, I want a fast iteration loop, but maybe I want that fast iteration loop on a local cluster or on a cluster running out in my data center. It really doesn't matter at this point, but in this case, we're targeting a local Kubernetes cluster. So what's allowing that reconciliation to happen based upon what's happening in my workspace? That's Tilt. If I have Tilt up and running, which you can go out and read the docs on how to get Tilt up and running. There's a really great simple Docker image to do it. I need to fill in a Tilt file. And in this Tilt file, I can put in my source image. The source image is not well named here. What this is meaning is the image in which my source, my raw source, not my compiled code, is going to be placed. Think of it more of, instead of thinking of it as an image, like a container image that I could run with Docker, think of it more of like an image layer that contains just the application bits that I'm writing, my Java code. It's going to be pushed there. So do keep in mind that if you're not using a local image repository and you're pushing to an external image repository, that could disclose things that you're not comfortable disclosing that you've put into your workspace. Heaven forbid you did it, but if you did put a username and password in a properties file, for instance, it would then end up in that image layer. So hence the reason why I really liked having this all local. You don't have to worry about that. I don't know what you would want to call it. That attack vector is not a great term, but that surface area. So it's going to upload to our local image repository that we stood up with our kind setup. The path that we're going to put in that container image is dot. So basically everything in the root directory and below in our workspace. The namespace we're going to put it to is just default. What we're then going to do is with tilt, we can say, hey, here's a custom Kubernetes deployment. All tap is just a bunch of CRDs, custom resource definitions on a Kubernetes cluster. I like to call it's Kubernetes native. It's native to Kubernetes. So in this case, we have an apply command, which is the Tanzu CLI provides an apply command that can turn a bunch of really neat things on, such as live update, my local path, my source image, and namespace. I'm providing as flags into the apply command because it's slightly different when running locally than when I maybe do my kubectl apply workload when I'm running the application, say, on a production cluster. So let's do this. Let's go ahead and do tilt up. Tilt comes with two ways of watching how the application is staging. We can stream the logs right here in our terminal, which is my personal favorite. But the way that really presents well is to open a browser, which can be done by hitting the spacebar. That will basically bring up tilt. And you can see here that it has a couple different things that it's monitoring, tilt resources. There's also some really cool things you can do with tilt if you want to go check it out online by reading the docs around having tilt files that point to multiple tilt files. So if you're wanting to emulate something like what you would have done in years past with Docker Compose, you can do that with tilt by saying, hey, tilt, import this tilt file, and this tilt file. And when you do tilt up, it will actually run all of those tilt files and monitor all those resources at the same time. So if we click on config server, what we're going to see here is it's building my artifact and building my workspace, or sorry, my artifact and my container. Right now it's resolving all of my Maven dependencies. If we go back to our terminal, we could hit the S key and it would just stream it into our console. Most developers probably would do it this way. Pick your poison. What's really great about this is we can see it going through the whole process where it's building our container image. It's just finished doing the Kpack part. So if we were to jump into another terminal and do KB builds, sorry.
So
KP
there was
builds.
a question.
Yeah, go for
Alexander Smirnov asked, does tilt play the same role as scaffold?
Tilt plays the same role as scaffold. So if you wanted to use scaffold, go for it. I have gotten my head wrapped around tilt. In this demonstration, I have seen nothing that would prevent you from also doing scaffold. The one thing I will say that I'm not sure of with scaffold, but I think would be okay, is this little live update piece that I'm going to demonstrate. I haven't quite gotten this little sync piece to work yet with scaffold. Not to say that it's not possible, but let's kind of watch the live update piece and see if that's possible and maybe someone could provide that. This is definitely an open dialogue of just information sharing, so feel free to share that in the comments. We're waiting now. Our image, let's kind of inspect our cluster. So we had our build. So when we did KP build, which is the build service CLI, KP builds list, we could see, hey, we've got our build happening here. If we did kubectl get image repository, we'll actually see two references. And let me kind of make this bigger so that it's easier to see. Of two image repositories that our cluster knows about. In this case, we have an image repository. This was our source image. This was the image that contained our source code. We have config server delivery, which actually is the container that contained our built image. And when we do kubectl get workloads, we're going to see that our workload is referencing just take note of this, is referencing our source image with this SHA. Okay, so I think, our app's up now. So we've built a container. We've built a container with Java, with a Spring Boot app from source on my local machine. I've then ran it through my supply chain, so my cartographer supply chain, and then it also then produced a Knative deployment. So if we were to look at kubectl get case service, we'd actually get back our URL to our Kubernetes, to our service running on Kubernetes. And there's a lot of moving components. There's Contour for routing ingress. There's Knative for serving and generating the deployments. So for instance, we didn't write a single deployment manifest, but yet we have a deployment running. We didn't run a case service manifest, but we have a case service running. And we have pods that are running in our namespace, which is our config server. If we were to do curl localhost 8080 or 888, we would get back a 404. Sorry, actually. So we have our actuator, our health check is returning that we're healthy. How do we know what port to go to? Well, Tilt actually is doing port forwarding for us. So config server is known to run on port 8888 and it's going to the internal port 8080. And it's providing that through just a simple port forward, no different than you would do through the Kubernetes or kubectl. The value this provides is this is now at a known location that the Spring Boot config server client actually defaults to because it has a client as well. So if I was in my Eclipse IDE and I wanted to get config server up on Kubernetes because it's just a fungible just component that I just needed for running locally, and then I also wanted to have an ability to consume that as part of my traditional Eclipse development flow where, you know, maybe I was still utilizing the Spring Boot dashboard that's in Eclipse. You could still do that technically because this config server is still running on a port that's resolvable by your local host. So, I mean, this is pretty interesting. So some things that happen in the day in the life of a developer is, you know, I've got to make a source code change, right? So let's clear this here. And in my case, my config server is actually producing these config documents. So if I were to curl localhost 8888/application, default, I would get back that configuration document about. This is a very config server specific thing, not really the point of the talk, just a thing that I can exercise in the config server. If I were to change default to dev, I would get back the dev configuration, which is the dev document here. We'd see hello world dev here. So we could see that it's serving up both application dev and application. It's up to the client to make heads or tails of these property sources. Not the point of the talk, just showing that the config server is working. Well, one of the things that, imagine that this was a source code change, such as I was making some sort of file change, like I changed an HTML document, changing a class, changing a YAML document. It's all the same. Let's modify this to modify. And hit save and go look at our tilt doc. What we will see is when that gets modified, hopefully, tilt should pick up that our source code changed and provide that modified document. Now, what's unfortunate is at the moment it's not doing that. Did I hit save on that? Let's see.
You made a change on application-dev.
Yeah. Let's see here. Deshaun, this isn't good for me, buddy. I don't know what I did wrong. I'm so sorry. Because I know that. Oh, you know what it might be? You know what it might be? My live update stopped. Let's do this really quick. My apologies.
So the whole idea here is
go ahead.
You can work on that, and I'm just talking about this local experience. I've been in that seat where you and I talked about Lyft, like that model of, hey, every developer gets a thing that has all the services running, and that's part of your onboarding. And they realized, hey, and this is even pre-pandemic, that they had so many of these developer instances up and running. They're like, just the loop on that takes a long time. And of course, they migrated, they came out with a new version, and they moved it onto the laptop where they had that closer, that smaller loop so that you can evaluate things. And when you hit save, yeah, it's automatically picked up. My experience was, every developer had their own set of configs, right? You had some local repository or local, secret store that had the way that you were deploying things, your feature flags, your passwords for your other resources, your keys, etc. And that's why this config piece is just a big step forward, right? And it's just showing an example of what's that?
Could it be the fact that should that first line say greeting instead of greeting?
It was designed not to matter, but I hope not.
Oh, okay.
But yeah, we're at this spot, and I'm doing it too, right? I'm running Tanzu Community Edition on my laptop here, on my laptop there, and just trying to explore, right? We have some new toys, and we're trying to figure out how good can we get the experience for local development.
Yeah, I want to see the combo of like this, because like the unmanaged clusters for Tanzu Community Edition use kinds, and it already you have the Tanzu CLI as a whole like thing with Tanzu Community Edition. So I'm kind of curious seeing all this stuff like running on Tanzu Community Edition.
Yeah, so that's a thing that we've already talked about is, and the version of the Tanzu CLI that he's using is different than what we'll get when we download Tanzu Community Edition. Some of the packages aren't available in both places. But I think the goal of the Tanzu Community Edition is to have kind of that open source alternative in those different spots. It's not going to be everything that's available in the commercial version of TAP, but for people that are just getting started, for people that are trying to have that local experience, I think Tanzu Community Edition, it's coming out with new releases all the time, and we're always getting more and more features under that umbrella. There's going to be a lot of similarities, but his purpose of this implementation is he's literally got workloads that are heading over here to Taz. He's got other workloads that are running on Kubernetes throughout the enterprise, and there's a gravity to those software supply chains that have matured over the last 5-6 years, and they see the value in that. And one thing he hasn't brought up is that the supply chains that his team is delivering, they have got what's the word I'm looking for? All of the compliance and regulatory stuff. They have all these things that are checked that you want to go to production. Guess what? Not only are you in production, but you've got the security team has already validated this. Governance has already seen it. It's fully transparent, and you get all of those benefits along with this path to production. So because the rest of that supply chain has all the checks and balances around container scanning, source scanning, where it's being deployed, the audit trail, the provenance of all the containers, this is just extending that paved path down to the user's laptop. And those are his stakeholders within the company.
Yeah. So let's answer the question as to what broke with my local. Okay. Day in the life of a developer, right? Day in the life of a developer.
That's what we do.
So there is a weird bug, and I think this might be more or less resulting from Linux, but I'm not quite sure if it's the case or not, where VS Code and the Java server that compiles your code can get hung up and in a bad state. And so basically I needed to restart that Java server that does the code compiling. And basically there was nothing in my target classes. This folder, target classes, had no content in it. And what Tilt is monitoring is my target classes. So when I was making a code change, nothing was getting published to my target classes. So for those following along at home and end up in the same position that I'm in, be understanding that you're monitoring target classes. If that's not compiling, you won't see your change in your target classes folder. So we are rebuilding everything right now because I just blew away my entire VS Code instance and brought it back up. And so my container will come up here in just a minute. And then assuming that that was the original problem in the day in the life of a developer, I should get this up in just a second. And then I should be able to show that this is not such a bad experience. But do understand that the goal here is you got to monitor that when you're doing live reload, you're really depending on the IDE to refresh and build the classes for you. You initially, the first pass here, Tilt said, hey, go compile these classes, and build service compiled them and put them in a container. After that point, we're going to be relying on Tilt to say, hey, here are some updated classes. Can you reload them in the container and restart the container without having to rebuild the entire container? So we don't want to take on this expensive process right now, which is it built the container. Now we're waiting for the container to get scheduled and started up on our local. So let's see here. Let's see. We should be container creating. So it should be coming up any minute now. Okay, now we're up. Okay, so now we come over here and let's just back to our demonstration. If we curl that local dev config, we can see that it says modified. Now we're just going to take modified away and hit save. If we look over at Tilt, yes, there we go. What we'll see is our source code got compiled and Tilt detected that, hey, these 5 files need to be synced over to the container because they're what are in our target classes file. Now, when we do a curl to that endpoint, we will see that it just says hello world. It doesn't say hello world modified. Just to show that I'm not going crazy, let's just do it again. Change this to 1, 2, 3, 4, 5, 6, hit save, go over to Tilt. We'll see that our container syncs those updates again, restarts the entire container. We're not doing dev tools in this case. We're restarting the entire container. And then when we query the endpoint, we get back 1, 2, 3, 4, 5, 6. So this is relying upon a plug. There is a plugin for VS Code. We're not relying on that plugin necessarily for this workflow. You can. In this case, we're just relying on the natural ability for the classes to be synchronized. I would imagine that I've tested this with Eclipse. As long as Eclipse is publishing your target classes and you're having Tilt monitor those, you will get a lot of these benefits because basically all it's doing is saying, hey, sync the files in this folder to this folder in the running container. Notice I'm not getting a new container every time. It's actually just reloading. It's utilizing what Kubernetes is great at, just restarting a process. It's just restarting the process and I'm getting a new, it's reading in the new whatever is changed. In this case, I'm changing a config file. It could be config, again, classes, could be HTML, anything that gets published to my target classes. In this case, that is completely customizable. You could do all sorts of additional assets here. Go ahead, Deshaun.
So yeah, this is just that, like the ability to make a change, evaluate. If you've got your other services, you're doing integration on your laptop, it's kind of a big deal to say, hey, yeah, yes, go ahead and make this change versus having to do a git commit in order to see it, kicked out the pipeline and land on some cluster somewhere.
In a perfect world, and this is our goal, I've given you the pipeline locally. Now let's think about that. I've given you the same pipeline that's going to go to production right on the same convergence loop locally. Your inner loop is the same as your outer loop from a moving parts perspective. So if you wanted to add additional things, all you need to do is package them up and make them installable, which you're going to have to do anyways to deliver them to Kubernetes. Give your devs the steps, and they too can get it running on their cluster, on their local laptop. We did forget one thing that I wanted to bring up. What would cause a new container to be created in my local iteration loop then? Looking at our tilt file, we have, it says dependencies. So target classes is a dependency, and POM XML in our case is a dependency, which is where our source, it's in our source code, but it is the linchpin of all of our dependencies. And we're not syncing like in this case, we're not syncing a bunch of jars through the live update capability. Maybe that makes sense someday, but we're not doing that here. So if we say move to Spring Boot 264, for instance, and hit save, that's going to go through a different convergence loop. It is going to redeploy and restart our existing running container, and that's because we changed a file in the workspace. But that doesn't necessarily mean that we are, that doesn't pick up the POM change. So to get the POM change to be updated, it's actually going to produce a new OCI source. And when that OCI source happens, we get a new SHA, which then is going to be picked up and reloaded by our Tanzu build service. No different than when we were talking about like when Java gets updated or a base OS image gets updated. Think of this as being the new integration point for your CI system. So let's say you did want to build all the source code and publish it and have, say in Jenkins or Circle CI. Right now, you may deliver a jar that you would Java jar my app and run it. Well, what you would have to do right now in current state is what we have demonstrated internally is we've taken that jar and published it to an image repository already compiled. And then we can take that jar then, and it's already compiled, so it would skip this step here of doing all this resolution. But right now we're resolving all the new Spring Boot 264 dependencies. We're building a brand new container. We're publishing that new container to our local image repository. And we had to do that because we had to resolve all those new dependencies. Then we're going to wait for the amount of time that it takes for it to discover that there's a new built container, which is about a minute or less. Once it detects that, it will do a rolling deployment from the old version, the old revision, to the new revision using Knative. So we'd be moving from Spring Boot 263 to 264. So we can see here that it's tracking a new pod rollout now. We've just picked up our Spring Boot 264 version. So we just rolled out a dependency tree update. That's the primary reason why you would build a new container, is if something that's dependency-wise has to be updated. But the live update could be all your own source code.
Awesome. Scott asked, is we were talking about the plugin for VS Code, and you'd said, hey, I'm getting most of those things with Tilt. He asked, even the debug or just the live update?
Yeah. So debug is where the plugin's going to start getting really interesting. And so remember, I'm running this locally, and we're at time, so I'm not going to dive into it too much, but kind of like a cliffhanger. Imagine then you could debug this workload. And again, debugging on a remote cluster, what is the biggest deficiency and efficiency? Latency.
Yep.
I don't want to be hitting my step button and it being like processing. And as we're all working from home, as we talked about, it's on tap at home. If we're working from home, working remotely, working at the coffee shop, working on our patio, working by the pool, we have latency in these realms of operating. So if I'm stepping through code and it's on a cluster running out in Oregon in AWS, and I'm in Kansas City, which is where I'm at, the latency is pretty high. So but if I have it running locally, should be pretty much the same as what I had when I used to run any debugger for my JUnits. It's a great question. And that's, I think, where I think a lot of really cool value is going to come, where you're going to have this ability to debug from VS Code, IntelliJ, hopefully Eclipse, so that you meet developers where they're at. Because every developer has a preference of what IDE they use. I'm demonstrating with VS Code because it's extremely lightweight and has a built-in terminal that's easy to navigate. That's the rationale for VS Code. If I was actually coding in Java, I'd probably be in Eclipse because that's just what I'm used to using. So,
good stuff.
Yeah, this is great.
Scott, and you are definitely, I'll queue up a little chit chat at some point because, birds of a feather. You guys will learn a lot from each other, and so will I. This has been awesome. We're on a journey to, what does it look like? The last thing you brought up is we're remote. Everybody's working from home. And that latency matters. Nobody wants to wait that long to get things done. And time is important. And you're taking the steps. The stuff that Scott has shown on recent shows has been amazing. And definitely, I think these journeys are going to merge some of the cool tips and tricks and patterns that we've seen over the last few weeks. So Bryan, this has been awesome. I'm excited. We're going to continue building this out, and we're excited to hear where things go with you and with your org, and then also with the community. Scott has definitely brought a lot of excitement to what we're doing with Tanzu Community Edition, and yeah, the Tanzu team keeps on delivering more features every day. Scott also shared that TCE 0.11.0 is planned for the end of March. So yeah, things are going to keep on coming, and this story is going to keep on evolving. We shared your public repository. So if anybody wants to take it for a spin or has feedback, PR is welcome.
Yeah, well, feedback is always welcome. Again, I did this on Linux. Definitely Minikube's an option as well. Mac OS, of course, is a target that would need to be figured out that I don't have as much experience with. And I'm hoping that most of this would work well on WSL and not have to change too much on Windows. But again, I think some of those things would be the proof is in the pudding and in the details. So we'd have to, but I think it's a start. It at least lays the groundwork, as you know, I like to do, in order to let others kind of provide value. So I hope someone takes away value from this today for sure.
This has been great.
Thank you for inviting me. It's very much appreciated. Thank you, Tiffany, and thank you, Deshaun.
Yeah, like Scott earlier was saying that the repo looked amazing and that he had a new weekend hacking session project.
Great. I know if he's busy because he's going to log an issue, I have a feeling. I just got this feeling that I'm going to get an issue. All right, y'all. Thank you, and happy Tanzu Tuesday.
Absolutely.
Thank you.
Thanks again.
Thank you.
Wonderful.
Thanks everyone for coming. And ever since we did the StreamYard thing, episodes are now with the same YouTube link, if you already have it, show up immediately after the stream instead of having to worry about me pulling it from Twitch and then doing all the fun stuff of getting it up, which I may or may not have time that I still have to do that with.
We're getting big time. This is amazing. Scott says,
so much.
If I open an issue, there will also be a PR.
Oh,
that's the way you're supposed to do it. Good etiquette. PRs are welcome.
Excellent. Thanks again. Well, this was fun.
Thank you.
Thank you. And thanks to Sean for getting this to happen.
Yeah, we're going to reach out. Brian's going to come back and he's going to tell us how it's gone, what he's changed. We'll see version 12 at some point. And yeah, I'm excited.
Can't wait.
Thanks.
Sounds great.
All right. Thanks.
Thank you.